Okay, this is in continuation to the discussion which we were having to understand the communication protocols in terms of deploying it on different satellites. So there is low Earth orbit, and particularly the low Earth orbit perhaps can be taken as the word cell. Cell is CELL, and what we are going to do is understand how different architectural framework has been utilized and can be utilized to draft the protocols in a manner whereby understanding the architectural framework becomes very important, particularly from the data point of creating the data servers. We have been talking about it for quite a while in terms of at a global landscape that servers perhaps they require a lot of energy, loads of water, and the way the orchestration is being orchestrated, at one end of the spectrum there is water pollution, at the other end of the spectrum there is scarcity of water. When I say scarcity of water, it means that water is more expensive. I mean, if folks have visited Singapore, a bottle of Coke, which is around 1.5 liters, is cheaper than a bottle of water. That is, I mean, in many countries you can have tap water, but generally tap water is not recommended as such. But yes, tap water is something which is available, but folks still like to have bottled water, and if you're traveling through United Kingdom or parts of Europe, you would see a water cooler which is dispensing water. Many a times you need to pay cents just to have a or gather water. But the point of contention here is to understand the observations when there is deployment of satellite. And let's talk about one of the use case applications, which is CICRO, that stands for Continuous Earth Remote Observation. So there is something called as, okay, let's understand this. So I'm going to get into this radar technology right now, and there's something called as SAR, and this can be part of the employer network in many ways. Happy to collaborate on this aspect as and when required, which is to understand the synthetic aperture radar and how these radars are technologically advanced as compared to the others which are currently deployed in any way whatsoever. Okay. We talked about spectrum. Now when we are trying to understand the role of any of these satellite communication protocols, one such protocol understanding is what kind of data is being collected and what is the source of data. So generally for the satellites, where it is deployed for relatively primitive functions. That includes emission, it includes reception, it includes sampling of data. Sampling itself is a very open-ended. Let's deep dive into it to understand what kind of samples can be taken. Then recording of radio and microwave signals. So there's something called as visible light, there's something called as invisible light, and a lot of tech band technologies have been developed. And the good thing is tech is ready, use case studies are ready. It's just the alignment with the ITU mandate for the 6G. We have submitted the report. That publication is scheduled for the month of November, and perhaps a lot is in the pipeline in terms of protocols ready, everything is ready. It's just that the conjunction and the understanding of the observers in terms of the civil society, in terms of the ITU network, the other authorities of the United Nations, they are going to play a very pivotal role. Although there is dilemma in terms of when the power shifts to one particular entity, then there are a lot of things which can happen around it. But right now, because it's a new world order, there is understanding that tech has to be deployed in the best possible manner. And for the deployment of the tech, it is very important to understand and appreciate the tech developed in terms of heat maps. Now, what are heat maps? Heat maps, if I talk about individual candidates, heat map is the aura or the whatever the mapping structure in terms of whatever tech we are deploying to understand the head count. Head count is basically the count of the candidate when the candidate is passing through a certain fixture. Once this is done, we have real-time messaging, navigation, and the best part, surveillance functions, which is dependent on multiple algorithms, and those algorithms itself have loads of modules. The data are serverless, so you can understand so much. The tech itself is so cheap to deploy, but has to be deployed in synchronicity with the stakeholders. And the identified nodes are going to play, and are playing, not going to play, I would rather rephrase myself, they are playing pivotal role right now to mitigate the SWOT analysis in the best possible manner. So all the threats are now an opportunity to deploy the observations as far as remote observation is concerned. So this is done. Let's get into the classification. I think that's one of the best tagging methods, which is, I'm not getting into CPC, someday I'll get into the CPC part. I'm just looking into the IPC part right now because the route let's take it for right now, let's take it as IPC, and then of course if somebody wants to get into the CPC and the understanding, they can get into that. Okay, we have Earth observation satellites B6461/1021. For the constellations, we have B64G1/1085. For the SAR image, which I already talked about, it is G0S13/9023. SAR image post-processing techniques. It is, I like the slicing part. It's easy because when you slice the image into zillion small packets, it transfers in real time. Combined with interferometric techniques. Then we have the synthetic aperture radar techniques, which is under the tagging of G01S13/90, which is radar and systems which is adapted for more than one application for mapping or imaging utilizing the synthetic aperture techniques. So we have the SAR technique, so that can be another discussion altogether, and we can do that as and when required. I need to just see this. Okay. Let me just see. So we are trying in understanding the deployment of this CICRO cell, which is basically, it has solar cells. Honestly, solar cells includes silicon, so one has to look into the silicon duping because that will create another menace altogether. So all tech is not good tech. How the tech is deployed with the deployment of the right stuff is the question we need to answer right now as stakeholders. We have space boom radio holographic cell, uplooking GNSS antenna. Then we have the fore antenna itself is EXO antenna, and then we have main RO antenna. There is radar transmitter and side and down looking antenna arrays. This is there. How does it work? Okay. So if I talk about NASA, there's a lot of emphasis on NASA right now. So what is NASA doing if I talk about the prior art? So most of the current NASA Outer Ring and NOAA Earth observing spacecraft, there is multiple copy of each NOAA satellite which is operating in the Earth's orbit. Having said that, we have, there's something called as JSON-1, we have Aqua, we have Sage-3, we have CloudSat, we have EQ1, we have Terra, we have Grace, we have SeaWinds, we have ICESat. That's the prior art. And if I have to look into the data set. Okay, now these survey arrangements. I think arrangement, so there's a very big difference in the spectrum when you're trying to understand the word arrangement and assessment. What is arrangement? Arrangement is certain, I would say I like the word modules and submodules, so I'll stick to that. So arrangement is modules, submodules, arranged, and assessment is an output, and how the output is taken into consideration is the question we need to answer. Then we have okay. Okay, obviously LEO is low or low Earth orbit. So how the distributed array of many small free-flying LEO sensors to accomplish what's currently is done with a few large observing platforms at altitude from LEO to geostationary orbit. So LEO stands for low Earth orbit. I think it's like around 1200, 1300 stuff. I'm not getting into the nomenclature right now. So we have this GNSS, that is Global Navigation Satellite System. It is an antenna to receive an GNSS signal, and the best thing here is how a satellite is utilized in a system. One needs to understand that, and perhaps in the new world order, whatever discussion or whatever theories or whatever equations were utilized beforehand is not going to work now, because the environmental factor, the historical data set are totally different, and you need to ask the right question to the stakeholders so that they understand what the planet is going through. It's very easy to say that leave this planet and settle out in another planet altogether. But what if we can just mitigate it and change over by changing the habit itself? Because a good farming habit is going to take the planet to the survival stage, and that's the need of the hour. So let's I'll just deep dive into this one. Because the costing itself is costing USDT 3 billion cost class. Okay, we have spectrum codes. I don't want to get into the spectrum code right now, but I can if I want to, but not right now. Let's do this. Let's understand this, and then we'll talk further on this topic. Okay, interesting. Let's So what is GNSS antenna supposed to do? What is the functional deployment of this antenna? It is receiving GNSS signals, example GPS, that is global positioning stuff, which is, all these handheld devices, it has it, okay? Then is Galileo for precise orbit determination and the atmospheric sounding. So sounds are going to play a very pivotal role. The question to be answered is, when you're talking about supersonic, how many folks are able to understand the supersonic power of the sound? And let me tell you, there are very few candidates on the planet living in some format or the other who are able to understand the supersonic way of communication. Then we have bilateral cross-link systems, which again includes modules and submodules. So we have two cross-link antennas at this point in opposite direction. One is for the forward altitude or leading trailing in the orbital plane. Second is unique spread spectrum codes. I love spectrum. That is like CDMA, which is assigned per satellite to encode transmissions, ensuring discrimination between the cross-link signals in the constellation. Then we have DSP, that is digital signal processor, correlating to receive cross-link signals from the adjacent satellite with GNSS derived timing to compute inter-satellite distances. Down-looking receiving antenna utilized here is GNSS-R, that is GNSS-Reflectometry or radio occultation to capture Earth surface or atmospheric signatures. When we talk about atmospheric signatures, these are basic parameters which are color-coded, which has nomenclature. Perhaps I was personally thinking, because I was coding stuff, and I realized that although the matrix, or when we talk about the binary stuff, everything is in 0 and 1s. What if we hypothesize particular combinations of 0 and 1s equal to certain parameters rather than the other way around, as to how the astrophysical stuff has been taught in universities at school level. I can't even imagine what being taught at the school level. Have no faith in that. But even at the college level, all these books which were written, that was not taking into account the historical data set or the real environmental data set. And there is a lot of I would rather say there's a lot of scope in that work also right now. Then we have dual path ranging, that is satellite calculation. Calculation is not the right word. I like to use the word evaluate. So if we talk about a spectrum, we talk about distances, we select one core which has a parameter. That parameter is itself, when the parameter itself is perimeter. It's thought-provoking, but not that simple, and simple at the same time. Simple and classic. That being said, it is basically evaluating two independent distances, example, preceding and following the satellite. So this is what I'm discussing. Let's limit it to the satellite communication protocols, which is GNSS time synchronization via the GNSS antenna. Then we have crosslink, time of flight via encoded signals, which is transmitted and received through the crosslink antennas. Then we have inter-satellite range, which is fed into a constellation wide Kalman filter to solve for real-time orbital states, improving the gravity field models. Then we have Earth rotation parameters, which includes polar motion and length of day. We need to look into Saint Martin's, which is on the map near the borders of Bangladesh. Then there's another place called as Bazar, and that place itself, there's a lot of seismic activity which is happening, and I happened to visit that place after the lockdown. It was a very difficult journey. Oh my gosh, I today if you ask me to go, I would rather say no, but I managed to visit that place. That's a kind of an island, which I believe has a lot of historical data set. Probably I'll study that, and that is already a heat map of mine. I've been there, studied the place the way I could, and it also has both the Chinese culture, which is not very well developed because perhaps over the years people have left or fled that place. And then we have the most powerful temple of Shiva. Lord Shiva temple is there, but just visiting that place, oh my gosh, it is not advisable, but happened to be at that place at a certain point way back in the historical data set after this lockdown of 2020. So yeah, went there. Then we have Earth observation deviation, that is gravity field recovery into satellite ranges, which enables the radiometry to resolve mass transport like groundwater, ice sheets, and sea level change. Right now, due to the weather changes in the nature, the sea level change, the water table and the like, it has gone to a level which needs to be re-evaluated, and we need to have these ETP kind of protocols everywhere so that we are able to reutilize the resources and get into the circular economy. Okay, so the highlight is the unique coding per satellite. So what is important is unique coding. That means it has to be a trade secret. Avoiding the crosslink interference in dense constellations, which is where the constellation is less than 100 satellites, while the dual direction range performs or provides redundant geometry for robust tomographic inversion of Earth's gravity, and that is able to understand the anomalies at any given point of time. That's very, very important. So the in-all understanding of this discussion is around the heat maps, and identified heat maps of the candidates would be very efficient on the Impala network to be deployed for the satellite communication protocols. Thank you for watching it out. Have a great reading, watching, and yeah, there is precision on the K-band, which is on the laser crosslinks. Have a great day ahead. Bye-bye.